Hello everyone, my name is Morteza Bashsiz. I am a Linux system engineer. At this series of videos, you are going to find out how to be a good Linux system engineer. So if you want to know, stay with me. Welcome to LSE episode 9. At this episode, I am going to talk about what is network address translation, what kind of NAT we have, and also what is the use cases of the NAT in networking. And also talking about what is firewall and how firewalls work in networking. So let's start it. This is the last episode of this chapter, the concepts of network and what is NAT? NAT is abbreviation of Network Address Translation. But before I start to talking about NAT, let me tell you a fact in sending request and receiving response between two endpoints in network. Imagine that we have a client here and a server here, and server is serving HTTP on port 18, and client wants to get service from this server. Then client starts to send request to the server, but okay, we have here IP for client, IP1 for example, and we have another IP, IP2 for server, for example. And when the client wants to reach on destination IP2 and destination port 80, it should generate a packet with source IP and destination IP, and also if you remember there should be another characteristic with source port and destination port. So here for a request for a packet we need source IP, source port, destination IP and destination port. It means that the client will open a random port. Usually it is more than 1024. A random port on client side, and then send the packet from random port. For example, here the server will receive a packet. For example, I don't know, with IP1, for example, port 5683 to destination port to destination IP IP2 and port 18. And when the client sends the request to the server, and after that server will process the client's packet and will send a response to the client, and the response will be transmitted over the same port. I mean exactly the port that the client sends it from. So here for the response, server will generate a packet with source of IP2, source port of 18, and destination port of IP1, and destination port of 5683, and will send it to the client. So this is the way of sending request and response, and the role of IP and port between two endpoints in networking. And NAT is abbreviation of Network Address Translation. And I wanted to describe it with two main questions and two main concerns in the networking. The first question is related to comparison between the available public IPs in all over the internet and also the devices that wants to use the internet and wants to reach the internet. So here we have internet, and on the left side we have public IPs, and on the right side we have devices. Based on what I googled, we have about 4.3 billions of IP addresses in IP version 4, yeah, some of them are reserved, and finally there is about 3.7 billions of available IP version 4 in internet. And what about the number of devices? You have your smartwatch, you have smartphone, you have your laptop, you have your PC, you have your camera, television that wants to update operating system from internet, and every device. I don't know how much is it, but the main and important thing is that absolutely, the number of devices is much bigger than the number of public IPs in the internet. So the question is how these devices are connected to internet and how they are working with the internet and how these things are handling. And the second point is about a security concern. Imagine that we have a data center here, which is a trusted network, and we are managing it with several servers inside. And on the other hand, we have another network which is untrusted, and we don't trust to this network. And we are using a private range internally here in our data center. And for security concern, we don't want to expose this private to outside of our internal and trusted network. So we want to hide it from outside to untrusted network. And this is one of the use cases of the NAT. So here we have two questions. First, how NAT helps to fix this issue. I mean the comparison between public IPs in the internet and the devices in all over of the world that want to use the internet, and also how NAT help us to protect our trusted network against untrusted network, and how we can hide our internal network to other networks. Now I wanted to describe the process of network address translation with a real example. Imagine that you have a NAT device and you have a client in a private network, and then we have a website like Google in internet, and we want to see how client A can reach Google by using NAT. And here we have a private network which is 192.168.5.0/24 in the left side of the NAT device, and you can see the client is with IP, and also we have an IP for our NAT device in internal network, and also the NAT device has another IP in public IP. So left side of the NAT device is private, and right side of the NAT device is public. And here, when the client wants to reach Google, it will generate a packet by the source of 192, 168, 5, 10, and it wants to reach the destination 7, 8, 9, 10, which is Google. Okay, and it sends forwards the packet to the NAT device. And since this IP range, I mean the private IP range, is not usable in the internet and you cannot use it, so the NAT device will change the source IP address to its own public IP address. I mean, so the packets will be changed like this: 1, 2, 3, 5, and yeah, the destination will be same: 8, 9, 10. Actually, the NAT device cannot send the packet with private IP address in the source because the private is not usable and it cannot work. Then it will change the source IP address to its own public IP address, which is available and usable in the public network in the internet. Then Google will receive the packet, the same source and the destination, 1, 2, 3, 5, and the destination is 7, 8, 9, 10. And Google processed the request and will generate the response for the sender of the request, and finally it will generate a packet by these characteristics. I mean, the source will be the Google because it is a response, okay, and the destination will be the sender's IP address when it wants to send a response. Then it forwards the response to the destination, which here is our public IP of our NAT devices, and here we have the same packet, 7, 8, 9, 10, with destination 1, 2, 3, 5. And here the NAT device will change the destination because this destination is not for our client. So we have another change here, and the source will be same, but destination will be changed to the private IP of our client in our internal network. And here we have the same source. And now we have a healthy sending request and receiving response. If we focus on the left side of our NAT, I mean in the client here, we have a request which sent from our client to Google, and then we receive a response from Google to our client, and it is okay. Then we have a request and successful response, and the client doesn't care that what's happened in the right side of the NAT device. it sends the request and receives the successful response. And on the other hand, Google doesn't care to the left side of the NAT device. I mean, Google is not aware of the private range of our network, and Google just understands the public IP of NAT device to the public IP of Google, and then yeah, it is okay. It doesn't care that yeah, there is some another host behind the NAT device, and it is client A with private IP, and this is the transparent layer with NAT device for Google. I mean, it's okay. So we are safe here. And the operation of changing source and destination IP by NAT device is called NAT. So here we have source NAT. We change the source because the source is private and it is not usable in the internet, in the public side. And then we have a destination NAT in the response, because yeah, the destination is our client, and it should be transmitted to the client. Okay, so source NAT and DNAT, destination NAT. And this is how NAT works and how NAT switches and changes the source and destination IP addresses. Now I want to make it a little bit complicated with putting several devices behind a NAT server. Imagine that we have 4 clients with different IPs that you can see here, and all of them want to reach Google by same destination IP, and also they want to reach Google by HTTPS, and yeah, this is the scenario that they want to open the https.google.com, for example. So the clients, when want to generate a packet, they will send the request from random port, as we talked before. For example, the clients are opening some random ports here, you can see. And yeah, always the destination port is 443 because it is Google and HTTPS, and also the IP is fixed. So here we have 4 clients that they want to reach Google by a specific port. And all of them send their packets to the NAT device. And here, for all of them, we have source NAT, SNAT, that happens here. And yeah, same as before, it will change the source IP address to its own public IP address. I mean, this IP is the public IP address of the NAT, and will generate the packets. And now we have 4 packets that the SNAT source NAT happened, and then it will forward the packets to the Google, and then it will receive the responses from Google, which all of the responses are the same. I mean, the SRC is 7, 8, 9, 10 from port 443, and the destination of all packets are the same, 1, 2, 3, 5. and it will send the responses to the NAT device. But the question is how NAT device will detect that which packet, which response is related to which client, and how it handles this issue. Actually, when NAT device wants to SNAT, change the source IP address, it will open random ports for each source for each client that it received in the left side. For example, it opens the port, for example, 62381 and port 62382, and here for this client 62383, and for this client 62384. So we have different source ports for different packets. So till now, in network address translation, we have IP which will be changed, and also we have an operation on port. And the port is answer of our question. I mean, the port is the point that a NAT will use it to detect which packet belongs to which client on the left side of the NAT device. Let's talk about it with a real example. Here you can see that we have 4 clients, and we have a table here that will help NAT device to detect that which packet is related to which client, and the decision making of this finding the client is based on the table like this. There in table we have source IP addresses, source port, destination IP address, and destination port. So imagine that client A when sends the packet to the NAT device will open port A for client A, and also port B for client B, and port C for client C, and port D for client D, and will send the packets to the Google. And if we imagine that public IP of the NAT device is 1235, for example, then Google will receive the packet like this: source and destination. For example, for client A, it could be like this. The source IP always will be the public IP of NAT device, and the destination will be always public IP of Google. 8, 9, 10. Destination port is 443, but for client A it will send the request from port A. So Google receives this packet like this source and destination. And when it wants to respond, it will generate the packet like this for source and destination. The source will be Google 8, 7, 9, 10, port 443, and the destination will be 1, 2, 3, 5, port A. Okay, so it sends the packet, the response of the request to the NAT device, and the NAT device will check the port of the packet, destination port of the packet. So it is A, it comes to port number A, and the NAT device will check the table. Okay, I receive a packet to destination port A from my public IP, so destination port A belongs to this client, and for operation of destination NAT, it will change the destination of the packet to this IP of the client and also this port. So it sends the response and receives the response as well. And this is the answer of the question that I asked at the first of this episode, that the comparison between IPs in the internet, public IPs in the internet, and the devices that want to use the internet. So now we know that with help of NAT, we can have thousands of devices in private network that they can use the internet. And yeah, this is our NAT device with just one public IP. So this is the answer. And we have thousands of private devices that they can use. So now we know that with help of NAT, we can have thousands of devices in private network that they can use the internet. And yeah, this is our NAT device with just one public IP. So this is the answer. And we have thousands of private devices that they can use the internet with just single public IP address. So now we know that with help of NAT, we can have thousands of devices in private network that they can use the internet. And yeah, this is our NAT device with just one public IP. So this is the answer. And we have thousands of private devices that they can use the internet with just single public IP address. And you can extend it to the larger scale. For internet service providers, you can now understand that how internet service providers provide the internet for millions of customers in their client side, and yeah, all of them don't need to have fixed and dedicated public IPs for every client, And for answer of the second question here, now we know the answer and how NAT can be helpful and can help us to hide and protect our trusted network range against the untrusted network with translating the addresses. And what is firewall? Firewall, in definition, is a physical or virtual network security device that monitors and filters the incoming and outgoing traffic based on the security policies in a network. And usually firewalls are located in the edge of the networks to protect the trusted network against untrusted network. So easy and so simple. And we have three main type of firewalls. The first and most simple type of firewall is packet filter firewalls that can understand IP, port, protocol, and they can filter packets based on these things in header of the packet. I mean, they can filter based on IP range, based on port, and based on protocol like TCP, UDP, ICMP, and the others. The second type of firewalls are NAT firewalls, which now we can understand that what is happening in NAT firewalls. They are protecting the internal network against the untrusted and external network. And the third type of firewalls are application layer firewalls. These type of firewalls are high-level firewalls which will monitor and filter the traffic based on the data in application layer. And one of the most and famous type of these firewalls are web application firewalls. They called WAF, and you may heard about the WAF firewalls. In the simplest type, imagine that we have an operating system and we have several services like SSH, HTTPS, FTP, SIP, RTP, and the other. And we enable the firewall on this operating system. It is important to know that the traffic and the packet will be transferred to network interface controller, and after that will be checked by firewall, and then if based on the policy rules in firewall, if it was allowed and accepted, then it will reached by transferred to the services, and then the services will get the request in application layer. And this is the main reason that when you drop a port, for example, I drop port 443 in my operating system, in firewall of my operating system, and then I will not see any log on my web server which provides the HTTPS service on the host. So if I drop the port, it will not be sent to the service. And service, for example, if there is Nginx will not get any request, and you will not see any log in access log of the Nginx if you drop a packet in the firewall, because firewall is working before these services, the application layers. But you drop HTTPS port on your firewall, and when you capture the packet on your network interface controller like TCP dump, you can see that you will receive the packets. So if you drop on your firewall or if you reject on your firewall, it does not mean that you will not receive that packet anymore. You receive the packet, but firewall will drop and reject it. And if you capture your network interface controller like TCP dump, and the applications like TCP dump, they are capturing the network interface controller, and the network interface controller is before firewall. And this is the reason that you can see the packets, the incoming packets on your network interface controller, even you drop them in your firewall. And in another case, imagine that you have a data center, you have several servers in your private network in data center, and you put a device as a firewall in edge of your data center, and here is untrusted network, and here is your trusted network. And yeah, the firewall will check and will protect your network, your internal network, your internal servers against the untrusted network. And usually a big mistake will happen here, and that is system engineers may see that, okay, we are here behind the firewall and we have a firewall in edge of our network, then we disable the firewalls on operating system. This is a very big and ugly mistake that it is common, and yeah, you may see in some cases some companies decide to disable their firewalls since they are thinking that, okay, we have another firewall in edge of our network, then we are safe, and we decide to disable the firewalls, and we don't like to get the headache of managing firewalls in single servers in each servers. This is not correct. This is a big mistake. And it is good if you always keep your firewalls configured on your operating systems, even they are behind the good and many firewalls, and even you think that okay, we are safe, just enable, configure as much as you can your firewalls in your operating system. And this is because of that this security could not be 100%. In any case, you cannot say, okay, I am 100% secure. So what we learned today, we learned about the NAT. We have the SNAT, we have the DNAT. We learned that in NAT we have IP and port, and how NAT helps to fix to solve the two main problems, two main issues about the count of the IPs and devices, and also about the security concerns to hiding your private network against untrusted network. And also we learned what is firewall and how they are working, and what is important in our infrastructure to always enable our firewalls, even we think that we are safe and we are behind several firewalls. And yeah, this is the end. Thank you for watching me. We are done here with the network part of chapter concepts. The next part will be about the metrics, in the concept of metrics that are really mandatory for a Linux system engineer to know about them. And it will be really interesting chapter. Don't forget to support me with your likes, your subscription, and also if you liked it, please share these videos with your friends. Till next episode. Bye bye.